Hi! If you ever had a problem regarding the PCB printing, when you want to use it urgently, you can't print it by yourself. You need to go somewhere in the PCB laboratory, or you need to place the order via online, which is take a long duration. Or if you want to own your PCB mining machine, you need a huge space to place it, and it costs so high. Assalamualaikum and very good day, Abid to all the panel. My name is Nur Amira Haning binti Azmi, women number DE180093. So today, I'm going to encounter that kind of problem matter by developing a sustainable development of a desktop printed circuit board PCB mining machine. Due to the rapid growth of technology, the usage and the utilization of PCB in modern consumer and electronic devices are increasing. Traditional method of using PCB, such as PCB etching machine, and it takes a lot of space. A custom PCB also will take a long period and require a high cost. By using PCB mining machine, user can produce their PCB at their home faster and environmentally friendly, while it still maintain in high accuracy. To solve the problem matter, a sustainable of a desktop PCB mining machine was proposed with the capabilities to the traditional method to reduce the development expenses and complexities. An aftermarket 3D printer motherboard and touchscreen display was used, and the motherboard, which is for 3D printing, has been modified to cater with the PCB mining requirement. The frame of the machine was designed by SolidWorks. Therefore, by applying that method, the PLA material was being used for the body part of the machine, and it support environmentally campaign. Next, a conventional desktop PCB mining machine can obtain from less than 300 USD to more than 3,000 USD, and a commercial that a viable machine with the LCD for the user interface is almost non-exist, and most of the previous design of the PC machine doesn't support environmentally design. Therefore, a sustainable development of a desktop PCB mining machine had been developed in this project to counter that matter. The aim of this project is to develop a sustainable desktop PCB mining machine with LCD display function. The PCB mining machine will be using 3D printing design. Therefore, the objective of this project to design and fabricate a sustainable desktop PCB mining machine and implement electronic control of the PCB mining machine by using 3D printer motherboard. Alright, so for the project scope, the float was used to design the structure of PCB mining machine, and mining firmware was utilized to control the machine. Third one, the frame of PCB mining machine using 3D printed to create its custom shape and size apart, and it safe prototyping cost and also support environmentally friendly. The next one, to control the motherboard of the PCB, it was using SKR V1.5 motherboard. A touchscreen display was implemented by using TFT version 2.1 LCD display, and then NEMA 70 stepper motor was used to control the gantries. And the most important thing that you need to be clear is the prototype of PCB mining machine that have been developed in this project only up to the movement of the gantries due to the time budget and constraint. Additionally, the component of spindle head will be left out for the future development. As you can see here, this is flowchart of the project planning. It begins by designing the machine and the frame in the SolidWorks. After that, it will print out by 3D printing, and the machine will be assembled either it meet requirement or not. If yes, we continue to assemble with the electronic components, and the mining firmware will be modified according to the requirement needed. After that, all the machine will be tested with the LCD for the gantries movement, and also to check whether the machine works successfully or not. If not, the troubleshooting process will be done. Since the body machine was using 3D printer, it was using polyacrylic PLA material. It's one of the most environmentally friendly filament on the market today. PLA is a biodegradable under canonical composing condition and will break down within 12 weeks. It will make more environmentally choices when it comes to plastic, contrast to traditional plastic, which could take centuries to decompose and up, creating out microplastic. According to the research, the carbon emission associated with the PLA production are 80% lower than the traditional plastic. Thus, this project strongly support environmentally friendly to help saving the ecosystem. The project was designed for the target workable bed area for the maximum size of the PCB tracking. It will be set up to 100 times 120mm. The dimension size of the PCB is 200mm. Thus, it achieved the target to have desktop size area. The concept to design of the sustainable development PCB modeling machine is based on the concept gantry movement simultaneously and in opposite direction, as they have the X, Y, and Z axis. Regarding the electronic component, it will be using the NEMA 70 stepper motor, it will be using SKR 1.5 turbo motherboard, TFT version 3.1 LCD touchscreen display, and Trinamic TMC 2209 motor driver. This is because this PCB modeling machine will be designed according to the print machine, thus it will save up more cost if using the same electronic component. This is the SKR V1.5 turbo mainboard using LPC1679 microcontroller, which has 120 MHz frequency. So the performance has been greatly improved by using firmware Marlin 2.0. And by developing PCB modeling machine, large storage is needed so that to store more data and upgrade and to configure the configuration in the firmware, it can be done through the SD card, which is more simple, convenient, and effective. NEMA 70 stepper motor has been used in the design with 1.8 degree step angle with 200 steps per revolution for the Z axis. Meanwhile, 0.9 degree step angle with 400 steps per revolution has been used for the X and Y axis. This step per revolution and the step angle is needed for the motor for the rotating movement of the X and Y and Z axis according to the instruction given. And this is the FT version 3.1 LCD touchscreen display that used to control up the program. It has two printing methods, which can use SD card and also USB flash drive printing. Thus, the printing process is even more easier and helpful, as it just can directly print throughout the machine by not connecting to the computer. Trinamic TMC 22019 motor driver is a silent motor driver for the stepper motor. It can operate in bipolar step from 1 to 256 step mode, and it designed to ensure the noiseless operation with maximum efficiency and the best motor torque. So by using this motor driver, it will implement the noiseless operation during this. For the self-heat design, the SKR V1.5 turbo mainboard will add as a controller with the Marlin version 2.0 firmware as the system conducting the printing process. The data from the G-code in the Marlin will be transmitted to the controller. The G-code will give the instruction either to move, how fast it moves, and throughout the path to move. There are 3 axes, and the X will be moved from the left to the right. Z will move up and down, and Y will move front and back. Alright, so this is the design of the PCB modeling machine. As you can see here, there are 3 stepper motor be placing at their own X, Y, and Z axis, and also been attached with the TFT version 3.1 LCD touchscreen display. And this is the back view of the design where the motor been placing. And this is the top view of the design. As I mentioned earlier, the spindle head was taken out from this project and will be using for the future development. And this is the left view and the right view, and also the bottom view of this project where the SKR V1.5 motherboard has been placed together with the TMC 2209 motor driver. And this is the project overview, which was using power supply unit for the machine movement. To measure the accuracy of the machine construction, repeatability test has been made, and this is the test for the X-axis. As you can see here, there are 5 testing has been made, and it only showing one of the testing has a little bit error, which is only 0.2% percentage error. Therefore, the movement of the X-axis give the height accuracy up to 99.8%, as same as the repeatability test for the Y-axis. As you can see here, there are 5 testing has been made, and only again showing one of the testing with the less accuracy, which is only 0.2%. Thus, based on this testing, the machine is accurate up to 99.8%. In conclusion, sustainable development of desktop PCB modeling machine was successfully built by using SKR V1.5 turbo mainboard and also with the 3 NEMA 70 stepper motor. By having LCD display, it can elevate user experience where the user can save up the file in the SD card and let the machine to work without connecting to the computer. This project can assist society in various ways, such as a long-term reliability, as the machine can run for hours without stopping. With the high precision components, This project has successfully developed a lower expenses of the machine with a good performance. Therefore, we continue for the demonstration process. Thank you and Assalamualaikum.